Today's lecture topic is about pressable ceramics. Um, After we pour up the model and we fabricate the dies, the next step is to fabricate the waxing copings or framework. It is very important to maintain the thickness of the wax for the coping. Minimum should be 0.5 millimeter, but again, check with the manufacturer instructions. Some of the manufacturers require 0.6 or 0.7 millimeter thickness for the wax coping. Also very important, when we design and wax the patterns, always make sure that there are no sharp corners, no sharp edges. The margin is flush with the margin of the die, and also check for the thickness of the wax, because in some places the wax might be a little bit thin. So if it's too thin, add a little bit of wax where necessary. When we're talking about sprueing for pressable, it's a little bit different than sprueing for porcelain fused to metal copings, in the sense that the ring, it's a little bit different, therefore the sprueing is different, and also the whole process of transforming the wax pattern into all ceramic restorations. So sprueing, attach the sprues in the direction of flow of the ceramic at the thickest part of the wax, so that smooth flowing of the viscous ceramic during the pressing is enabled. So it's very important to kind of visualize how the molten material is flowing during the pressing stage. Depending on the number of patterns to be invested, it can be either 100 grams or 200 grams of investment per ring system. Bridges also must be pressed in the 200 grams ring system, because that's allowing for more thickest investment on either sides of the walls of the ring and also from the top of the ring. Very important, each ingot for all pressable ceramics can hold a certain amount of wax pattern. So it's important to measure, to weight using a jewelry scale to weight the wax patterns with the sprues. So for instance, for Emax system, a small ingot can hold up to 0.7 or 0.8 grams of wax patterns with the sprues. If it's a large ingot, can hold up to 1.7 grams of the wax patterns with the sprues. The guideline for, or the steps for sprueing, depending on the restoration, the ratio of the investment, it's a little bit different, and we're talking about the ratio of special liquid with water that can give us the retention of the restoration. So the same principles for PFM in terms of the investment, it's apply here. So for if you remember, for the PFM, the rule was more water, less retention. So the same idea applies here. Must be when we sprue for the pressable ceramics, must be at least 10 millimeters between the wax patterns and the silicone ring, so that the length of the sprue should be at least 10 millimeters. The maximum height, the wax patterns plus the sprue, should be of 16 millimeters, not more. if there is only one pattern sprue, exactly like we were talking about when we sprue for the PFM, sometimes a vent or a blind sprue must be added, um, because that's ensure that the function of the furnace works properly when the pressing stage takes place. So this is the correct sprueing, and we see here a different type of sprues. So depending on what type of restoration we sprue, we have to select the proper gauge sprue. So for inlays, onlays, we can use a thinner sprue, but for, let's say, a bridge or a full contour restoration, we should use a wax that is a little bit thicker. Also, again, every time we sprue, we have to be careful not to sprue, especially for the inlays and onlays, not to sprue it on the margin or close to the margin. Investing. Investing, it's also, if we're using the EMAX system, which is developed by the Ivoclar Vivadent company, then they have their own investment system. We have to make sure that we're using the investment that it's necessary for the pressing procedure. And for that matter, the company developed two types of investment: the traditional or investment, which we can invest and let the ring set and then put it in a cold oven and for the burnout phase, or we have the speed investment that can be placed in the oven when in the burnout oven when the oven is already reached the temperature. It's very important, he says here, to not use the bubbleizer on the wax object when we're doing the sprueing. And we have to be careful also, like I said, when we mix the investment, read the manufacturer instructions, because if we're using the conventional or we're using the speed, the ratio of liquid water, it's different. The ratio to the powder to the liquid, it's different. So read and understand the manufacturer instructions in terms of the investment. The same for the mixing of the investment. And if always it's recommended that these investments to be mixed in a vacuum mixer. When mixing the investment, especially the powder, we have to be careful not to breathe in the powder, because that contains a quartz powder which is detrimental to us. So it would be good to wear a mask. Also, be careful and to use small brush or a very like a PKT instrument to flow a little bit of the investment over the pattern first to kind of fill up that gap and make sure we don't have any voids or any bubbles on the investment. This is very important. When we put up the silicone ring inside the base, we have to make sure that the silicone ring is placed correctly and there are no gaps between the base and the ring. And then we have to allow the investment to be set following the manufacturer instructions. Those investments are not hygroscopic, therefore they can be just left on the bench to set, but we have to be aware of the timing. So the manufacturer instructions is going to tell us for how long we have to leave the investment to set completely. Um, and this is the investment procedure. So when we pour out the investment into the ring, always use a vibrator. Don't put a vibrator on high because that may dislodge the wax patterns from the ring. So small vibration, and make sure that the investment it's coating all the surfaces and there are no air bubbles trapped inside. So after the investment is set, we can move to the next step, which is the burnout stage. And first, we have to remove the base and the silicone ring from the investment, and then the invested mold should be trimmed on the top to break the seal on the investment and to allow gases to be expelled during the burnout stage. Make sure when you take out the ring, no investment it's inside the hole of the ring, because that's going to be trapped during the pressing time. So that's going to create a miscast. Also, make sure that you read and understand the temperatures. So at what temperature the ring should be heated, and for how long the heat soak procedure should be taking place, and also what other requirements are necessary. For instance, if you have more rings to put in the oven, then allow the heat soaking phase to be extended by 10 minutes for each additional rings. Again, for pressable ceramics, even though sometimes it's the same system but using different pressable materials, they require, each material require a different approach in terms of the burnout phase. So for Empress system, which is the similar to the Emax system, but because that material is a little bit different in composition, that material required, the Empress system required that the plunger and the ingot should be preheated before pressing, which is not the same for the Emax system that we're using in our labs project. So for the Emax system, the plunger and the ingot should not be put in the burnout oven. Also, when we're ready to do the pressing, we have to use a pressable oven and select the program that is necessary. And again, using Ivoclar Vivivent system, we have the pressables ovens from Ivoclar. The programs are already set up in the oven. We just have to select the proper program when we do the pressing. And the most important thing is to select the size of a ring, if the ring is 100 grams or 200 grams, and also what type of material we're pressing. So for us, we're pressing layering ingots, and also what type of ingots we're pressing. We're pressing a low translucency, high translucency, medium opacity. So when selecting those programs, we have to make sure that they correspond with the material that we're going to use for pressing. So when we're ready, after we select the program for the oven, we're ready to insert the invested ring into the pressable oven. We're going to retrieve the ring from the burnout oven. We're going to turn it upside down so the whole of the ring is exposed. And we're going to insert first the cold ingot and then the plunger. So once we have the ring with the ingot and the plunger ready, then we can set it into the pressable oven. And we have already selected the program, so we can just press start and the program, it's going to start by himself. It's automated, so once the pressable program is ending, the oven is going to open automatically, and we're going to know that that procedure is done. So this is an illustration of how the pressable procedure takes place. So we have the pressable oven. We select the program needed. We insert first the ingot and then the plunger. Then we put in the ring with the ingot and the plunger. We're going to select the program and press start. And once the program is done, we can retrieve the ring, let it bench cool before divesting. So after cooling to the room temperature, the invest ring might crack. So that's not something that it's going to be critical. Critical is for the investment to not crack during the burnout stage or during the pressable stage. That means that the investment wasn't mixed properly or the ratio of powder liquid was not correct. So if everything went well with those stages, then it should not be any cracks during the burnout or the press stage. But if there are some little cracks during the cooling of the ring, that's okay. The next stage would be to deinvest the ring. Usually, it's recommended to take a plunger, a clean plunger, put it against the ring, and mark where the plunger is. So we're gonna see in the next slide. So we take a new plunger, we're going to put it against the ring, we're going to mark where the plunger is, and then we can cut it using a disc. And that's going to expose the button of the pressed patterns. And then we can use sandblaster to clean up the investment. Again, sandblasting those all ceramic restoration, we have to be very careful because they're glass-like material. So if we put too much pressure into the sandblasting, or we're using a different sandblasting material that it's more coarse, that can produce fractures or into the wax patterns. So very carefully, we have to use the correct pressure. It's recommended for Emacs to use glass beads to sandblast it. And especially around the margins, we have to be careful to not put too much pressure when we deinvest. So again, when we deinvest, we have to be careful also at the distance we keep the tip of the sandblaster. So too close would produce too much of sandblasting on the pattern that can produce those microfractures. So very important when we sandblast, it's the material that we use for sandblasting has to be fine, not coarse. Also, the distance, how we keep the sandblaster tip to the wax, to the pressed patterns, very important, and the pressure. Um, so after the press patterns are divested, and this is mostly for the system, the Emax system. Some other pressable materials might not need this procedure, but for Emax system, we need to really clean up uh, the patterns using an acid. So we're using uh, hydrofluoric acid. Usually that's mixed with water. Always make sure when you mix the acid not to spill it. Hydrofluoric acid, it's very dangerous because it burns the skin. So take precautions, and when you mix an acid with the water, make sure you don't spill anything. Make sure you wear protection. Goggles is very important. So we mix acid with the water to dilute a little bit of that acid, and then we're gonna put it in the ultrasonic um, unit to clean up any of the remaining investment. Usually, um, this is like an oxide layer that forms on the all ceramic pressable, and like I said, this is more characteristic for this Emax system. Some other pressable systems, their material doesn't form that oxide layer during the pressable, so therefore this step it's not necessary. After that oxide layer it's removed, we can just sandblast it again very lightly, just to make sure that there is nothing left on the surface of the pressed restoration, and then we can stem it, and we're ready to move to the next step, which will be to remove the patterns from the sprue, to cut the sprue. So again, we have to be careful using a diamond disc. We can cut the sprues, but because this is glass-like material, we have to be careful to not put too much pressure when we do the cut. Otherwise, you can fracture the restoration. Also, when we do the cut, don't cut it too close to the pattern. So it's recommended to leave a little bit of the sprue in there, so that gives a little more strength to the area of the restoration where we do the cut. Once we have the cut done, the sprues are removed, then the next thing will be to use a stone, like a green stone, to remove the bulk where the sprue was, and then we can use a diamond burr to reshape the restoration, and then make sure that a restoration fit correctly. So very important, after cutting the sprue and kind of recontouring the restoration, we have to put it back in the die to check the fit. Um, Sometimes might be a little bit of distortion. Uh, so use a magnifying instrument to, or microscope, to see if the margin of your restoration is flush with the margin of the die, and also look inside the restoration to see if there are any bubbles or something, if the restoration doesn't fit properly on the die. If you need to trim inside, um, be very careful. Don't over trim it, because that's going to make the restoration loose, and we want to the restoration to have good retention. Once we're done with the bulk trimming and the recontouring of the restoration, we can again lightly sandblast the restoration and using a steamer just clean up the restoration from any debris from the grinding. The next step would be to use, if we do monolithic restoration, a full contour crown or ceramic crown, the next step would be to stain and glaze. Usually all the ingots that we use, they come in different shades to match the natural dentitions of the patients, but in some cases, some patients, they might have um, characterizations on the natural teeth that we need to copy. So we can achieve that by adding those stains. Usually the stains, they're a little more intense. So when we're ready to apply stains, we have to be a little more careful not to make them too intense. Especially on the occlusal surfaces where we want to put maybe a little bit of brown to mimic the pits and fossa, to make sure that it's very gentle. It's not something that it's very obvious, because then the patient is going to look at the restoration and is going to say, oh, it looks like I have a cavity in there. So we have to be careful with how we use this. Again, make sure that the program for staining glaze is selected correctly in the oven. There are some pressable ovens like the ones that we have in school that they have a dual purpose. So they're pressable ovens, but also we can do a firing of the porcelain. So if we decided to use that oven, again, switch the program to firing, find the correct program for staining glaze or layering the Emacs program, and then start the program. So the first step will be to do the staining. We stain the crowns, we put them in the oven, we bake them, they come out, we let them cool completely, and then we can apply the glaze. Again, this system, they have different type of stains and glazes, and we have to be accustomed with how they function and how we should apply them. Some of them, they might need to be applied on a thick layer. Some of them, they come in a paste, and we just need to apply the glaze in that thickness that it came with as a paste. Some of them, they're powder, and we have a glaze liquid. We need to mix it. So we have to be aware of the thickness of the glaze that it needs to be for the proper application. When we're ready to bake the crown for the glaze, the final stage for the glazing, select the proper program in the oven or put the temperatures and the holding time as required by the manufacturer. Also, sometimes there is necessary to add on some porcelain, layering porcelain. For instance, if we do a cutback on the restoration, especially for the facial, for a better aesthetics, then we can apply a build-up porcelain. And again, every time we apply a porcelain, we have to make sure that we select the proper program for baking. Okay. This is the cutback technique. So let's say we wax up to the full contour and we're ready to reshape and cut back the facial of the the parent. So using the same technique, we're going to use a diamond disc to cut the parents from the sprue, and then we're going to use a stone to remove the bulk where the sprue was, and then also we can use the same stone to reshape and cut back on the framework. When we cut back, we have to make sure that we don't cut back too much and make the coping weaker. So always use a caliper to measure the thickness of the framework. And also, like in this case, if we want to cut back, especially for the anterior teeth, to build up the mamelons, don't use a disc to do the cutback, because usually the disc it's very thin and can produce micro fractures into the restoration. So the best way to do the cutback and to do those cuts for the mamelons will be to use a stone. Before applying the layering porcelain, it's indicated again to lightly sandblast the surface where the build-up porcelain is going to be applied, and also clean it up by using a steamer. So then we can start using the build-up porcelain, and for the Emax system, the porcelain, the build-up porcelain is called Emax Ceram, and they come in different application. So we can have the body porcelain, we can have the shoulder porcelain, we can have the incisal porcelain. We have to match the ingot. So let's say if the ingot shade was A2, the patient shade is A2, then we have to use a A2 dentin, build-up porcelain, and incisal porcelain that corresponds to the A2 shade. Okay. Also, after we build up and we're ready to firing, use one of the pins that it gives stability to the restoration in the oven. So we have to make sure that the pin is stable into the firing tray, but also the restoration doesn't move inside the pin, so it's stable. Okay. Some of the materials might require a wash firing, which kind of allows for a better bonding between the porcelain and the framework. So this is the wash firing, where this liner porcelain is applied for a better bonding. It's not always necessary to use it, but also when applying this material, sometimes we do it to increase the value of the color of the restoration. So even though, let's say, the dentist came out and said, the shade of the patient it's A2, maybe it's a A2 but has like maybe grayish undertones. So we can use this layering material to kind of induce that grayish color into the restoration. And so once we have that fired, we can start applying both the dentin and the incisal porcelain. For each of them, we have to be careful, first of all, how we apply the porcelain. So make sure that the porcelain is dry enough, it's condensed enough before firing, and also that we use the proper and the correct program in the baking oven. Again, we have to be careful also when we apply the porcelain to shape it in the way we want to shape it, and especially when we talking about a bridge. What's different between all ceramics and PFM uh, framework for the bridge? For PFM, we can do the connection between each unit a little bit thinner because metal, it's not brittle. But when we have pressable, we have to be careful that those connections between each unit are strong enough and they're kind of bulky enough to um, be to provide enough support for the restoration. Also, the EMAX system, the manufacturer recommends that only 3-unit bridge can be made using a all ceramic system. So we have to be careful also in terms of the design of the framework and how many units can we do using the system. So once we have the bridge completed with, or the restoration completed with the build-up porcelain, we're ready for recontouring. Again, we can use the diamond burrs to recontour where necessary, and then sandblast it and steam it, and we're ready for applying the glaze, the stains and the glaze like described before. So this is the whole process in pictures of building up using Denton and Incisal, and also the restoration finished using the stains and glaze. Thank you.